Okay, we're in section 4.1 of Al Grosch's book, Developmental Math 2. In this video, we're going to talk about the properties of exponents. All right, we're going to zoom in a little bit here so we can talk about this example where we see this expression. There's two numbers in an exponential expression. The big number, the 2 here, is called the base, and the little number to the upper right is called the exponent. This does not mean 2 times 4. So let's put that right here. It's not 2 times 4. Instead, what it does mean is there are 4 2's being multiplied together. And that you can see right here in this example. The exponent tells you how many of this base you're going to multiply together. And of course, 2 times 2 would be 4, times another 2 would be 8, times another 2 gives you 16. So that's the basics of the exponent. So now we're going to talk about what happens when we start putting expressions with exponents together. So this is 2 cubed, or 2 to the 3rd power, times 2 to the 5th power. And what that means is 2 to the 3rd power means there are 3 2's multiplied together, and 2 to the 5th power means there are 5 2's multiplied together. When we multiply those two expressions together, we still have a whole bunch of 2's being multiplied together, so this base is still 2. But now we have 1, 2, 3, 4, 5, 6, 7, 8 2's multiplied together, so this becomes 2 to the 8th power. There is a shortcut for this kind of expression, a multiplication of two exponents. As long as the base is the same, and here you can see they're both the bases are 2's, you can just add the exponents together. And that's how we get a base of 2 with an exponent of 8, by adding the 3 and the 5 on the base of 2. So we're going to go down here and do this example. These bases are the same. They're both 3. So the new expression will have a base of 3. The exponents are 2 and 8. So we can just add them together and we get 3 to the 10th power. So we're going to practice on this page, this one rule, and it's stated again up here at the top. X to the a times x to the b equals x to the a plus b. That just means that when the base is the same, you can multiply these expressions by keeping the same base and just adding the exponents. So here at number 1, the base is negative 5. So we'll keep the negative 5, and we use the parentheses to hold that negative in. The exponents are 6 and 8, so the new exponent would be 6 plus 8, which gives us an exponent of 14. So negative 5 to the 14th power. In number 2, we have x to the 5th times x cubed. Now, we don't have the multiplication symbol here, but when we have variables right next to each other like this, it does mean multiply. So the base is still going to be x. To multiply these together, we just add the two exponents. So we're going to add the 5 plus the 3, and of course that gives us x to the 8th. In number 3, there are two bases. X to the 7, y squared, x to the 6, y. Okay, and there's no exponent on the y. When you see no exponent, it's implied to be an exponent of 1. So when you have more than one base like this, what you're going to want to do is rearrange these a little bit and put all the x bases first. Because remember, with multiplication, it doesn't matter what order you write it in. It still comes out to be the same thing. So if we put these two x bases first, we're going to have x to the 7 times x to the 6, and then the y bases next to each other, y squared, y to the 1. This is going to become x, and we're going to add the exponents on x, and that makes 13. And this is going to become y, add the exponents on the y, and this becomes 3. X to the 13th, y cubed. On number 4, there are a lot of bases here, but you can recognize that this is all multiply, so it doesn't matter if we rearrange all these bases. So that's exactly how we're going to start. We're going to put the coefficients, the 4 and the negative 3, here in the front. So we'll have 4 times -3, and all I did was move them both to the front. And then I'm going to put the a's behind that. So I have a to the 7, a squared, coming from here and here. And then I'm going to put these two bases behind that, the two b's. So we'll have b cubed and a b. And of course, there's no exponent on that b, so we're going to put a 1 there. When there's no exponent on a variable or a coefficient, it's implied to be a 1. And sometimes it's helpful to write the 1 when we start to simplify. All right, now, these coefficients should be multiplied. So 4 times -3 is -12. These a's, to multiply them, we add the exponent. So this is going to be a to the 9. Same thing with the b's. To multiply them, we add the exponent. So this is going to be b to the 4th. Okay, number 5 looks really confusing because we have the minus signs inside these parentheses. What you cannot do is you cannot just put the cube on the x and the cube on the 4. It doesn't work like that when you have plus or minus signs in the parentheses. Exponents don't distribute inside parentheses when there are plus and minus signs. What you do need to recognize is that this base, x minus 4, has an exponent of 3. This base, x minus 4, has an exponent of 5. They are the same base, x minus 4. So you're really just multiplying two of the same base. And to do that, you just add the exponent. So the base is x minus 4. The exponent is 3 plus 5, which makes 8. So don't try to make it more complicated than it is. You won't be able to put that 8 inside this parentheses because of this minus sign here. So this is as simple as it's going to get for you. All right, on the next page we have another rule for exponents. So let's make it a little bigger here. So when we look at this, this is 3 to the 5th power divided by 3 cubed, and that's the fraction bar means divide. So to give an example of how this is going to work, we're going to expand it. So I'm just going to write these out on the top and the bottom. You can actually see it down here, but I'm going to write it out while we're talking about it. So we're going to have 5 3's multiplied together, and that would be the numerator of the fraction, over 3 3's multiplied together in the denominator. And of course, you know the rules of fractions already. Any factors that match in the numerator and the denominator, you can cancel because they just make ones. 3 over 3 is 1. 3 over 3 is 1. So we can cancel these factors that match, and we're left with just this, which is a base of 3 and an exponent of 2, because there are two of them multiplied together. So 3 squared. All right, now the shortcut is you can keep the base when the base is the same and just subtract the exponents top to bottom. So this would be a base of 3, 5 minus 3, an exponent of 2. So what do we have down here? This time we have a base of 4. And again, we can write this all out. 1, 2, 9 4's multiplied together over 6 4's multiplied together. I have too many here, don't I? Where's my eraser? All right, let's write it all out again. We have 9 4's over 6 4's. All right, now, when you have these, you can cancel any that match. So we're going to cancel all of those, and we'll be left with a base of 4 and an exponent of 3. And of course, again, the shortcut was just to subtract the exponents, 9 minus 6. So on the next page, we're going to use a shortcut. We're not going to write all these out. Okay, you can see the rule here. x to the a over x to the b equals x to the a minus b, so a minus b. Now this only works if the base is the same. If I had two different bases on the top and the bottom, this wouldn't work. In the example 1, we have a base of -3, so the base is still going to be -3. If I subtract these exponents, 7 minus 3, I get an exponent of 4, and that's how this rule works. On number 2, I have a base of x. If I subtract the exponents, 5 minus 2, I get an exponent of 3. So when you're dividing the same base, you can just subtract the exponents. On number 3, all right, there's lots of different bases in here. We're going to start with the coefficients, the 10 and the 2. And this is not subtract, this is divide. This is 10 divided by 2, which makes 5. So we're going to start there. And then we're going to look at the x's. We have a base of x. If we subtract the exponents, it will be 12 minus 8, which makes 4. And then we're going to do the y's. If we subtract these exponents, it would be 9. Okay, there's no exponent here, so don't forget this is the invisible 1. So we actually have an exponent here of 9 minus 1, which makes 8. And then the z's, which are really interesting. If you have z to the 4 over z to the 4, the exponents 4 minus 4 make z to the 0. It just means that this is 1 that's all gone. It's reduced. It's all reduced off. So there are no z's in your final answer. On number 4, we're going to do the same thing. We're going to start with the coefficients of -6 over 9. All right, this isn't going to divide like the 10 and the 2 did. So this we're just going to reduce. They're both divisible by 3. So we're just going to reduce this to -2 over 3. I'm going to suspect that we need this whole fraction bar, so I'm just going to pull it way out like that. All right, the a's. We have a to the 6 over a to the 4. If we subtract these, that gives us a squared. We're going to write the a squared up here on the top. In the next section, we'll talk about why it's on the top. But for now, just trust me. The b's cancel. b5 over b5, they all cancel off. There's no b's left. The c's are on the bottom, so we'll leave them there. And this is multiply, so we're going to use that rule we learned in the last section. When you're multiplying the two bases, you add the exponents. So this would be c to the 4 plus 2, which makes c to the 6. All right, we have another rule on this page, which is about exponents being stacked up on the same base. You can see this is 5 cubed to the 4th power. This means there are 4 5 cubes being multiplied together. So let's write them out like this. 5 cubed, 5 cubed. There are 4 of them multiplied together. Well, each of these has 3 5s in it. That's what 5 cubes means. So how many 5s does that turn out to be altogether? Well, you can see the base is all 5. How many of them are there? 1, 2, 3, 4, 5. 12. There are 12 5s. So this is really 5 to the 12th power. There's a shortcut here. When you see two exponents stacked up on the same base, you can multiply those exponents. The base is 5. 3 times 4 makes 12. So this is 5 to the 12th power. When we look down here, the base is 2. The exponent is 5 times 3, or 2 to the 15th power. I do want to make a clarification here because sometimes I see some confusion. This expression, 2 to the 5th cubed, is not the same, that means not equal, as 2 to the 5th times 2 cubed. All right, these are not the same thing. In this expression, there's one base. The two exponents are stacked up. This is 3 groups of 5 2s. This comes out to be 2 to the 15. Over here, this is 5 2's times 3 2's, another 3 2's. The base is still 2, but here we add the exponents, and this becomes 2 to the 8th, and you can see they are not the same thing. When the two exponents are stacked up on one base, we multiply them. When the two of the same base are being multiplied together, we add the exponents. So that's just a clarification of these two rules. All right, on this page we have some practices for this rule. Here's the rule stated again. X to the A raised to the B, two exponents on one base, is x to the A times B. So here's the base is 10. The exponents are 5 and 12. So they should be multiplied together. 5 times 12. This is 10 to the 60. 5 times 12 is 60. On number 2, the same base of x. These two exponents should be multiplied together. So 7 times 3 gives us x to the 21. On number 3, there's a lot of bases in this parentheses. What you want to make sure is that this exponent goes on all of these bases. Now, just to clarify, earlier in the section we had a base that had a minus sign in it, and I told you can't bring the exponent in. There's no plus or minuses here. Everything is multiplication, so go ahead and bring the exponent onto every base in here. So this is how I like to write this. The first base is 2. It's going to get an exponent of 3 because this 3 is going on this 2. The second base is x cubed. It's also going to get an exponent of 3. Why does it have 2 3's on it? It has a 3 here in the parentheses already, and then this 3 is going to go also on it, and they end up being stacked like this. The second base is y to the 4th. It's going to get an exponent of 3. And the third base is z. It doesn't have any exponents, so that's the implied 1, and it's going to get a cube on it. So this cube went on the 2, it went on the x cubed, it went on the y4, and it goes on the z cubed, on the plain old z, on the z1. Now we're going to expand. 2 cubed means 2 times 2 times 2, which gives us 8. X cubed cubed, this is where we multiply these exponents, so this becomes x to the 9. 3 times 3 is 9. Y to the 4 cubed, this is the same rule. They get multiplied, so 4 times 3 is 12. And z, again, they get multiplied. 3 times 1 is 3. So 8, x to the 9, y to the 12, z cubed. Now, on number 4, we're going to do the same process. We're going to put this 4 exponent on everything in the space. So we're going to start with the negative 3. And it's going to get a 4 on it. And then we're going to have a squared. And it's going to get a 4 on it. And b to the 8th is also going to get a 4 on it. And then we're going to use our exponent rules. Well, this means negative 3 used 4 times. So negative 3, negative 3, negative 3, negative 3. All of that makes positive 81. This is the multiply rule. So this becomes a to the 8th and b to the 32. All right, number 5. Do not be scared of it because it has a fraction in it. It's okay. It's not that scary. When I look inside this fraction, I should always look to see if there's anything in here that I can reduce or simplify before I do anything with this cube out here, because it will make my cubing easier if I get this down as simple as possible. It turns out with this fraction that this is already simplified. There's nothing else you could do here. The 3 and the 2 don't reduce. There's no other a's or b's or c's to go with these variables. So this is already reduced. So all we need to do is put the 3 on each of these bases. So we're going to write that out here. So we're going to have 3 cubed coming from here and this cube out here. And the next base is a to the 5th and we're going to cube it, and b squared, and we're going to cube it, and that's the numerator. The denominator is going to be 2 cubed, c to the 4th cubed, and then we just need to simplify. All right, 3 cubed is 3 times 3 times 3, which is 27. A to the 5th cubed, multiply these exponents because they're stacked up. That makes a to the 15. B squared cubed makes b to the 6th, 2 times 3. In the denominator, 2 times 2 times 2 is 8. C to the 4th cubed makes c to the 12th. Now you always want to check your fractions to see if there's anything that reduces, but it didn't reduce in here, so it's probably not going to reduce out here. 27 only has the factors of 3 and 9, and neither of those are factors of 8, so we're good. And this is your final answer.